So now we're going to look at kinematics, test 3, which is mainly projectiles questions, if I'm not mistaken. So you're going to be looking at SUVAT in the X and the Y direction. So the I and the J if it's vectors. So let's have a look. So we've got unit vectors I and J, I being horizontal and J being vertically upwards. So we've got it in vector form. In some ways this is easier because we can split it straight away. So whenever you've got any projectiles questions, your brain's going to go, I'm thinking horizontal and I'm thinking vertical. And before I even read the question, there are some things I know. Right, so SUVAT, horizontal, vertical. I always know horizontally my acceleration is 0 and vertically it's minus g. So if I start anything, I can put that in. And then let's have a look. We're given the u. And here we don't need to resolve or use the angles or anything because the u horizontally is 9 because that's your I component and vertically it's 12. We know that v equals u plus at. So if a is 0, v equals u. So horizontally, it never changes. We're trying to find h, which is a vertical h. And that's vertically trying to find this h here. And let's read the question now. It's telling us the velocity at the instant it passes through the point A. So the velocity over here is lambda I minus lambda j. Well, we just said that we know that the v, u and v doesn't change. That means lambda has to be 9. So if that's 9i, that's going to be minus 9. And if we want to find h, we can just use v squared equals u squared plus 2as in the vertical direction. So v is minus 9, so we've got minus 9 squared equals 12 squared plus 2 times minus g times h. Rearrange that for h and we get 3.2 meters. We've got the minimum speed of the ball as it moves from O to A. So the minimum speed is going to be your horizontal squared plus your vertical squared square rooted, but your horizontal is never changing. So there could be a point where there's no vertical speed. So therefore your minimum speed is always just your horizontal speed. So 9 meters per second. Find the length of time for which the speed of the ball is less than 12. Okay. So we're thinking about v in both cases. Now, horizontally, remember the v never changes, it's just 9. Vertically, however, v equals u plus at, u is 12, a is g, so minus gt. And gt. And we're talking about the speed, which is Pythagoras of that. So the speed is 12. Okay. So what we need to do is find out what that t what the values of t are. So we've got, if we find out when it's 12, we can then work that out. So we've got 9 squared plus 12 minus gt squared equals 12 squared, so 144. So we get 12 minus gt all squared equals 144 minus 9 squared, so 63. We take the square root, plus or minus root 63. We rearrange that, and we get gt equals 12 plus root 63. So t equals 12 plus root 63 divided by 9.8, which gives us 2.03. Or we could have gt equals 12 minus root 63 and t equals minus root 63 divided by 9.8. And we get 0.414. So therefore, the speed when it's less than that is going to be the difference between the two. So you're going to do 2.03 minus 0.414, which gives you 1.62 seconds. And then it says suggest one other refinement that would make it more realistic, and that would be to consider all the dimensions of the ball. So you could say, well, the ball isn't just, you know, a particle. Right, next question. All right, small point is projection. Right. So this is a very standard question, and a lot of these are, and they always work the same way, and they're actually a lot easier than sometimes projectiles are made out to be. So essentially, whenever you've got a projectile, you've got to sort of think of your XY axes. And this is from the ground, so it's doing that. And we've got our U here. So it's projected with a speed U. There's going to be an angle here, which is theta. And if I resolve this, I'm going to have U sine theta, U cos theta. Right, I'm starting at 0 and I'm ending in this case at A. So I'm going to think of horizontal and vertical. So straight away, horizontal, vertical, SUVAT. Before I do anything, I can put the 0 and the minus G in. And now I can see my horizontal, I'm going till here because that's what I'm concerned with, is O to A. Vertically, my displacement is 0 because I'm starting at the same place I'm ending. So that's 0 here. This is going to be U cos theta. This is going to be U sine theta. And the T, when it gets to the end, is the same in both cases. So we're going to say, okay, what will OA be? So we know that S equals UT plus a half AT squared. However, if A is 0, that's just going to say S equals UT. So from O to A is going to be U cos theta T. And then I look at what they want. They've not got a T there, so I've got to use the horizontal one to find an expression for T. I can use the same formula. S is 0 because the displacement was 0. U sine theta T minus a half GT squared. Right, so I can move that to the other side. I get a half GT squared equals U sine theta T. We're not concerned with when T is 0, so we can cancel out the T here. And we get T is the same as U sine theta. It's the same as, bring the 2 up, 2U sine theta over G. And now we can take all of this and substitute it into here. When we do that, we get OA equals U cos theta multiplied by 2U sine theta over G, which gives us 2U squared cos theta sine theta. And then we know 2 sine theta cos theta is the same as sine 2 theta, and we have our solution. So although it looks all convoluted, it's actually quite straightforward, and you've got to use a little bit of trig. You never get away from trig. Okay, next bit. A golfer hits the ball with a speed 25. Okay, so we now know that U equals 25. We require OA to be at least 40. So we've got everything we need to be able to answer this question. So we can say 25 squared. So even if you didn't get A, use it. They've said it's, you know, so you're using what you found. 2 theta over G, and it has to be at least, so greater than or equal to 40. We're going to rearrange that for sine 2 theta. It gives us 0.627 dot, 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 dot. Inverse sine of that gives me inverse sine 0.627, gives me 38.829. And its sine, and my rule for sine is 180 minus. So the next one along is 141.17. And I can't be bigger than that because it'll go past this point. And we divide both ones by 2. We're not concerned. We want the largest one, so we don't really care about the 38. The bit we're concerned with is that. So we get 70.6. Okay. Given that theta equals 30 and the golf ball is more than 3 meters above the ground for t seconds, find the value of t. So we go back to our SUVAT. We're talking about above the ground. So we're talking about our vertical ones. So S equals 3. Remember, this was u sine theta. So that's going to be u sine 30. And has the u changed? No, we know the u is 25, so actually it's 25 sine 30. We're trying to find t, and we know a is minus g. So again, we can use s equals ut plus a half at squared. So we get 3 equals 25 sine 30. Sine 30 is a half. So 25 over 2t minus a half gt squared. Plug that into my calculator, and I get t equals, I should get find the value is more than 3 meters. Okay, so you get 2 values, 2.282 and 0.268. So when it's more than, it's between those 2 values. So we take them away from each other. So big T is 2.282 minus 0.268, which leaves you at 2.01. Right, next question. Okay. A small ball is projected with speed u from the top of the cliff. Exactly the same. We see a u, we start resolving. We get some marks. So we've got u sine 45, u cos 45. We know that it hits the ball, so we know it's going here. So horizontally, it's moved 100, but let's put that in. So SUVAT, we know that's 100. If it starts here, this is minus 25 because we're starting at our O line and we're ending down there at point A. We've got u cos 45, u sine 45, 0 minus g, and we're not given a time. Okay, so t and t. Right, so S equals, you'll see that you start using the same one every time. So we've got 100 equals u cos 45t, because A is 0, so that's horizontally. Vertically, we've got minus 25 equals u sine 45t minus a half gt squared. 2 equations, 2 unknowns. You can eliminate t by rearranging your horizontal one, and you end up with u equals 28 as required. The greatest height is going to be your vertical height, but it's when v equals 0. So you should remember that from, your AS SUVAT. So your greatest height is when your vertical v equals 0. So we're going to use v squared equals u squared plus 2as. So 0 squared equals 28, which is what we just found, sine 45 squared minus 2gh. I solve that for h, and I get, so 28 sine 45 squared divided by 2 times 9.8. So I get h is 20, but that's not that's the height above my starting point. and they want the greatest height from the ground. So your greatest height is going to be 20 plus 25, so 45 meters. Okay. So now we're taking air resistance into account, but we still want to end up at the same point. So now we've got resistance, but we want to end up with the same point as before, which means we need our speed to be greater to start with. So here you're just saying your new value will be greater than 28. And a further refinement would be, I don't know, the spin of the ball, the size of the ball, the shape of the ball, anything to do with the fact that you've modeled the ball as a particle. Right, question 8. In this question, use G as 10. Oh, that's nice. Okay. A ball, okay, a boy throws a stone with a speed u. The point is 18 meters above. Then it hits 36. Again, this is the same. They all are the same. S equals ut plus a half at squared. But let's go through the process. Resolve up and down. U sine alpha, u cos alpha. We've got tan alpha equals 3/4. So sine alpha is opposite over. And cos alpha is 4/5. Okay, we're going to do vertically, horizontal and vertical, SUVAT. We're going to think about what's happening here. So that's going to be 36. That's going to be minus 18 if we consider where the starting point is. We're going to have u cos alpha, which is 4/5. So 4/5 u, 3/5 u. That doesn't matter in this case. 0. They told us you G is 10. And that's going to be T, and that's going to be T. So S equals UT plus a half AT squared. When we consider that horizontally, we get 36 equals 4/5 UT, because obviously there isn't any acceleration. And if we consider it vertically, we get minus 18 equals 3/5 U minus a half G, so 5T squared. We want U, so we want to eliminate T. So T equals 36 times 5 divided by 4, so 45 over U. We can sub that in. Minus 18 equals 3/5 U minus 45 squared times 5. So a really big number, 45 over U squared times 5. Multiply the U squared up, and you should get I'm trying to find U. Yeah, that's right. Minus 18 U squared equals 3/5. Oh no, we don't need to do that. Sorry. I overcomplicated life here. Minus 18, 3. Oh, I've missed a T. That's why. Okay, I thought it looked strange. Right, S equals UT plus a half AT squared. So clearly there used to be a T there. That's more like it. So we've got to multiply the 4/5 U there as well. Right, that makes more sense, because the U's cancel, and then we can solve that easily. Okay, you can tell it's getting late now. Times by 5. And when I solve that all, I end up with U equals, let me put it up here, because obviously then you've got U squared on its own, so it's really easy. So you get U equals 15. So So u equals 15. And then we've got the speed, sorry, that's u equals 15. I'm not sure whether you heard me talking into my iPad. So you substitute it in, you're still using that same formula we keep using. Right, so now we want the speed when it's 10.8 meters above sea level. Right, so 10.8 meters is over here somewhere. So in terms of where it started, we want it 10.8. It means that it's down, this distance here is 7.2. Okay, so we're going to think about, we care about the vertical drop. So v squared equals u squared plus 2as. We're trying to find the speed, so we're trying to find the v, because the horizontal speed never changes. So v squared equals u sine alpha squared plus 2a is minus 10, and we said we're going down, so minus 7.2. So v equals 15, and that's our vertical speed. Our horizontal speed is simply u cos alpha. So we found u to be 15. Cos alpha is 4/5. So that's just going to give you 12. And your speed is the magnitude. So your speed is going to be 15 squared plus 12 squared square rooted, which gives you 19 meters per second. So suggest 2 improvements. Use air resistance, consider the dimensions of the stone, the shape of the stone, the same as before. Okay. Question 5. Right. 5. That 5? Yeah. Right. This is actually a really good question to make sure you understand. Sorry, that's scrolling around. What we're going to do is we're going to consider P and Q separately. And then we're going to think about what combines them. So we've got the points A and B, we've got 2 balls that are coming together and then they meet at some point. So let's think about what that means. So if we think about particle P, we'll have a horizontal and a vertical, and particle Q will have a horizontal and a vertical. So SUVAT. If we say particle P, if I call that the amount it moves in this direction, I'm going to call that X. It's kind of an X direction, XP. And actually for particle Q, I'm going to do the way it's moving, which is that way. And this is going to be YP. This is going to be XQ, and this is going to be YQ. Right. So this is going to be 20 sine 30, 20 cos 30, u sine theta, u cos theta. So for P, I've got 20 cos 30, 20 sine 30. Here I've got u cos theta, u sine theta. I'm not going to worry about the V's just yet. 0 minus G, 0 minus G. And at any particular point, the T's are going to be the same. Potential, actually, no, they were not necessarily. So we'll just leave that blank as well. That's probably easier. Okay. We know that they collide when T equals 2. Okay, so we can put 2 in there. And when they collide, their heights have to be the same. So at the point they collide, we know that YP equals YQ. We also know that the distance they would have traveled will equal each other. So if we think about it, the distance they will have traveled when they collide will be XP plus XQ will have to equal 50 because it will equal the total distance of A and B. Right. What do we want to find out? Find the velocity of P at the instant before it collides with Q. Okay, so that's not too bad. So remember the velocity, the horizontal bit doesn't change. So we know the horizontal velocity of P will always be, so the V of P will always be 20 cos 30. And vertically, instant before it collides. So we've got to think about both. We're going to have to think about the horizontally, we've got to think about the vertically. Vertically, we know V equals U plus AT. So for P, so VP, U is 20 sine 30, I think I wrote theta here, minus 2G. So we plug that into our calculators. We're going to get 2 times 9.8, 20, 2 times 9.8, and we're going to do 10 minus answer. We get minus 9.6. So we know that horizontally, we've got 20 cos 30. Vertically, well, if you like, it's going down. We've got 9.6. So our velocity is going to effectively be like the speed. So we're going to do the square and square root. So we're going to get 20 cos 30 squared times 9.6 squared, square root answer, and you get 19.8. 19.8 meters per second, but because it's velocity, we've also got to think about the angle, which will be the tan of, so it's going to be this angle here of how it's traveling. So we're going to do tan minus 1 of 9.6 over 20 cos 30, which gives us 29 degrees. Okay, so that actually didn't need those bits of information that we put up here, but we do need it for part B, which is 6 marks. So we know that YP equals YQ, and we know that the sum of the two distances. So let's do the sum first. So we're going to get 20 cos 30 t, which is times 2, plus u cos theta times 2 equals 50. The only unknown there is u. Okay, well, we can solve, oh no, and we haven't got theta. So we got a simultaneous equation with making the vertical ones the same, which will be 20 sine theta, so ut times 2 minus a half g2 squared equals u sine theta times 2 minus a half g2 squared. Right, this is the same on both sides. This can go. 2's the same on both sides. That can go. So we now have u sine theta equals 20 sine 30, which is 10. We're trying to find both of them. So we're going to substitute in. I would suddenly substitute in for u because you'll end up with cos over sine. Or you can substitute in for sine theta. It doesn't matter which way you do it. You solve them and you end up with theta equals 52 and u equals 30. I hope that makes sense. You've got 2 equations, 2 unknowns. One limitation, again, the same thing. You not take into account the shape of the ball, the size of the ball. You know, you're considering them particles. Right, last question. Okay, so we've got, start off in the same way, resolve u sine alpha, I guess it looks like an alpha, u cos alpha. What are we told? We're given here the highest height. So we're thinking about it vertically. SUVAT, vertically V is 0. And we've got u sine alpha. We're trying to find S, which is, let's call that well, we know what S is. So we know this distance here must be 1. So S is 1 minus G. So we've got V squared equals U squared plus 2AS. So 0 equals U squared sine squared alpha minus 2G times 1. We rearrange that, we'll get U squared sine squared alpha equals 2G. And we divide by sine squared alpha, and we're left with U squared equals 2G over sine squared alpha. So that's actually relatively easy, and that's quite nice. The point T, so this is a random point here, is at a horizontal distance 20 and a height 0.75. Right, so let's think about SUVAT, and we're thinking at that point T. So from where we started, that point T horizontally is 20, but vertically you started, and how much have you moved down? So vertically, you're going to go from 2 to 0. So that's going to give you minus 1.25, because you're starting here and you're ending here. So if you go along here, that space here is minus 1.25. Okay, we know we've got 0 minus G. We've got U equals, so we've got U cos alpha, U sine alpha. Not worried about those at the moment. And we want to find out this big T. Oh, we don't need to find the big T. It's just the point T. Okay, sorry. That's just going to be small t, because we're not told where that is. Okay, so like everything else, S equals UT plus a half AT squared. So 20 equals UT cos alpha, and minus 1.25 equals UT sine alpha minus a half GT squared. We're going to rearrange this one. So rearrange number 1 for T. So we get T equals 20 over U cos alpha. Substitute it in wherever you've got a T. So when I substitute it in, I'm going to substitute it into there. I get minus 1.25 equals U times that. Can you see the U's cancel? Actually, let me write it out for you. So you've got U multiplied by 20 over U cos alpha sine alpha minus a half G T squared. So it's all of that squared. Okay. Now this cancels with this. Sine over cos is going to give you tan. So I get minus 1.25 equals 20 tan alpha. And here I'm going to get, well, I know I'm going to get a half G. So 4.9 times 20 squared times 20 squared, which gives me 1960 over U squared cos squared alpha. But in part A, I know what U squared is, so I can sub that in. So it's because I don't have much space. Let's just plug it in here. So our U squared is the same as 2G over sine squared alpha. Cos squared over sine squared is cot, but because it's 1 over, I can flip it and get tan. So I get minus 1.25 equals 20 tan alpha. If I do 196 divided by, I'm going to get minus 100 tan squared alpha. And now can you see you've got a disguised quadratic? So you've got 100, this is not very nice, sorry, it's very messy. If I go from here up here, I've got 100 tan squared alpha minus 20 tan alpha minus 1.25 equals 0. I can plug it into my calculator as a quadratic, and it gives me tan alpha is a quarter, inverse tan of a quarter, and you get alpha equals 14 degrees. Right, I know that's really messy and quite horrible, but it is 9 marks, and it's using trig again, because like I said, you can't get away from trig. One limitation to the model is that the ball could have different dimensions, the spin of the ball, maybe wind. And if we were going to find the time taken to travel from A to T, okay, so our alpha was 14. We want to find the time. Okay, I'm going to clear all of this, but use the values that we had. So if I want to find the time, I first need to find my u, because then I can use 20 equals ut cos alpha. So u is going to equal the square root of 2 times 9.8 over sine 14 squared, which gives us 2 times 9.8 over sine 14 all squared. Sorry, I'm sticking my calculator. Squared, square root answer, and we get 18.3. We can therefore put cos alpha, which is, so t will be 20 divided by 18.3 cos 14. So 20 divided by answer times cos 14. And I get 1.13. And that's 1.13 seconds. Okay, breathe. I hope that's okay. That is a little bit complicated. Leave me a note or send me a message on social media with your email address if you want a more step-by-step solution, or that, especially the last question, was a bit muddled and fast. And I'll try.